Okay, so to find the area of any one of these regular hexagons, you can split them up so there's an equal amount of isosceles triangles. Here there would be 6 triangles, here there would be 5. And if you found the area of one of them, then you would just take it times 5 here, right? Find the area of one of these, take it times 6, right? Remember, the area of a triangle is base times height divided by 2. Correct?
Right.
So for this one, the area would be the base times height divided by 2 times 6. Here it would be the base times the height divided by 2 times 5, because there's 5 of them, right? Okay? Now, you could sure do it that way, but there's a formula, which actually the formula is already up here. In any regular polygon, those of you that take, do any of you take the Accuplacer? Or when you take your ACT, you need to know this. The distance from the center to a vertex is a radius, but from the center to an edge is called an apothem. Okay? From the center to an edge. So if you draw from the center straight to the edge at a 90, it's the apothem. So in this formula, the apothem is just the height of the triangle, right? Base times height, but it's now called an apothem.
Oh.
And then we take the base, right? And we're taking this whole thing times 6. So what that ends up being is it ends up being the perimeter, the distance around the object. So instead of base times 6, they just put perimeter. So it's here, it's also, there's a base here, and we're taking all this times 5. Well, if we just do these two, that's just the perimeter. So that's the formula for any regular polygon.
Oh.
And that's on your formula sheet that I gave you. Times the apothem. And it's AP over 2. Doesn't matter what order you do it in. Perimeter times apothem, apothem times perimeter divided by 2. Okay? So some of these are very easy. The pentagon is the hardest. But we're going to do the easy ones today. So, the center of a polygon, everyone would know what that is, right? It's the middle part, like in a triangle. It's this part. The center is the point you'd put your compass on to draw a circle around. Now the way to find the center is you draw the perpendicular bisectors. Okay? Radius of a polygon is just from the center to a vertex. The apothem is from the center to an edge. Now, when I draw that in, what does that form?
Wait, what did you say the radius was?
Radius is from the edge, from the center to the edge of a circle. So center to the vertex. So what does this form right here?
A right triangle.
A right triangle, which means you're going to use Pythagorean theorem, sine, cosine, tangent, and the special triangle rules. Central angle of a regular polygon. Yesterday when we did that worksheet, when they drew the dotted lines, that's a central angle. Because remember, a central angle is the vertex is in the center. Okay? Now, the equilateral triangle has its own formula. You can use AP divided by 2, but if you notice, is it on the bottom of your formula sheet? Yep. Formula for equilateral triangle It's the square root of 3 times the side squared divided by 4. That's some different numbers to put in there, but it's the easiest thing to do, because if we used AP divided by 2, we would have to figure out what this value is right there, because that's the apothem. Now, if we use this formula, we don't have to figure anything out, because we need to know a side, so you just plug whatever the length of the side is into that formula. So like in this one, the area is the square root of 3 times whatever one side is, they're all the same, squared, divided by 4. So when you do this, it's just using the calculator. Square root of 3 times 6 squared divided by 4 is, round these to the nearest tenth again, 15.6 units squared. Most of these aren't labeled, so you wouldn't have to label them as far as what the unit is. But if you want to make sure you don't forget, just put U squared. Here, if it's 4 squared roots of 7, using the formula, it's the square root of 3 times 4 square roots of 7 squared divided by 4. Now, when you use the calculator like this, you're going to want to put it in parentheses. So square root of 3 times, put a parenthesis, because both of these got to be squared. And you get 48.5. Okay? Now, just to show you how the other formula works, remember, any regular polygon, you can use the formula AP divided by 2. The perimeter is easy to figure out. The perimeter of this is 18. The apothem is harder. So the way you figure that out isn't that terrible hard. In an equilateral triangle, what's each angle going to equal? 60. So then if I go like this, what does this equal? 30. So what I've got here is a 30, 60, 90. And I know that this piece right here is 3. So what's the short leg?
3 squared.
3 squared to
3 squared to 3 divided by 3. It's the short, or the long leg times the square root of 3 divided by 3. So the apothem then is that. So you would take 3 square root of 3 divided by 3 times the perimeter, which is 18, and you take all that divided by 2. And you'd get the same formula as if we did the other one. Okay? So, don't forget, a lot of times people forget about this formula, equilateral triangles. When you take your ACT test, you get a formula sheet, and that formula is on that formula sheet for
So
equilateral.
we just use this sheet and figure out what formula we use for
Yeah.
this row.
Now, we're going to skip to there we go, a square. I want to do a square. So, if you've got a square, all you need to know is one side, right? So if that's 8. Again, this is a regular polygon, so we can do AP divided by 2. So the apothem is from here to here, which we got to figure out. So on a square, remember this is the apothem. It's a 45-45, and this would be 4, so this would be 4, right?
Right.
Because the legs are the same. So the area is the apothem times the perimeter. 8, 8, 8, and 8 is 32. divided by 2. Okay? So that is 64, I think. Yeah. Alright, I was hoping someone would say that. On a square, do you have to use this formula? No, because it's just length times width. 8 times 8 is 64. Okay? Now, the tricky part is sometimes they don't give us the sides. Sometimes they give us just the apothem. Alright? Now, if they do this, it's really not that hard. But you need to know your rules. You need to know this is a 45-45. And on a square then, these two pieces would be the same. Which means each side is 6. So length times width is 36. Alright? Now the little bit tougher one is if they give us the radius. If that's 10. Now again, if you forgot the rules for 45-45, you can use the Pythagorean theorem, you can use sine, cosine, or tangent, but what you need to do is figure out what this is. So the shortcut is, if you don't know them, it's going to save you a lot of time if you memorize them. If you know the hypotenuse, what do you do to find the leg?
Double it, square root times 2 or 5 times.
It's half the hypotenuse times the square root of 2. So that means the whole leg is 10 square roots of 2. So to find the area, you take 10 square roots of 2 times 10 square roots of 2, or you can put it in the calculator, parenthesis 10 square roots of 2 squared. When you do this without a calculator, 10 times 10 is 100. Square root of 2 times the square root of 2 is square root of 4, which is 2. Because remember, 2 times 2 is 4, and the square root of 4 is just 2. Remember, if you take a square root of 7 times the square root of 7 is 7.
Oh my gosh.
Anytime you take a square root times itself, the square root just cancels itself out. So this ends up being 200 right there. Okay? So the triangles and the squares have their own, well, the square, you can just use length times width. The equilateral triangle has its own formula. Tomorrow we're going to do the pentagon and hexagon ones. So today we're just going to do the triangle and square ones.